Okay, we're going to look at the homework, and we are going to do problem number 1. A1. It says a 12-volt storage battery. So we want to write our given. We're going to write our find, and for every single problem, we're going to draw a schematic diagram. Every single problem. If you do not draw a schematic diagram, you're not getting credit for your homework. A 12-volt storage battery. So that's what's coming out of the battery. So we're going to say VT is 12 volts. It's connected to 3 resistors. So I'm going to number the resistors. I'm going to call them R1. Even though they don't do it in the problem, that's going to help me to understand this, and so I won't make any mistakes. R2 is equal to 15.3 ohms, and R3 is 21.6. The resistors are joined in series. So before I do, A, I'm going to find A, the equivalent resistance, which I'll call RT. B, what is the current in the circuit, IT. All right. So before I do anything, what I'm going to do is I am going to draw a schematic diagram. So first I'll start off with my battery. And now I'm going to draw 3 resistors. Now, these are in series because, again, there's only one path for it to flow. What if I drew it like this, and I drew my 3 resistors like that? Is this also in series? Yes, because you see how there's whatever's flowing through one is flowing through the other ones. So it doesn't matter if my diagram looks like this or looks like this, that still shows series. So how do you tell whether something's in series? You look and see, is the current going through them the same? Is there only one path for it to flow? So that's what a series circuit looks like. So R1 is equal to 6.75, R2 is equal to 15.3, and R3 is equal to 21.6. So for part A, I want to find the equivalent resistance. So RT is equal to R1 plus R2 plus R3. So RT is equal to 6.75 plus 15.3 plus 21.6. So RT is equal to 43.65. Now in this problem, I'm going to go beyond what they're asking to solve for because I want to explain how there's a foolproof way in circuits to always check your work. Always. Always. This is one area when I was in high school and I took physics. My physics teacher had an education degree in chemistry. Probably the only physics he took was in high school. And he never understood this, which means he couldn't teach it. I'm going to teach it so you completely understand, but what I need you to do is I need you to pay attention. And that when I go beyond what a problem asks for, there's a reason for it. All right, the next part says to, what is the current in the circuit? So the current, what I want to find is IT. So what I'm going to do is I'm going to use Ohm's law. V is equal to IR. But I'm going to apply Ohm's law to the whole circuit. So I'm going to say VT is IT times RT. So if I rearrange the equation, IT is equal to VT over RT. The problem is, there is no problem. I already found RT. So VT is 12 volts divided by 43.65 ohms. So IT is equal to 0.275 amps. Now what this means is, remember, in series, the current is the same. So if I asked you what is I1, I2, and I3, I1, I2, and I3, that's the current going through here, the current going through here, and the current going through here. Well, in series, they're same. So IT is equal to I1, is equal to I2, is equal to I3. So I1 is 0.275, I2 is equal to 0.275, and I3 is equal to 0.275. They're the same. The great thing about circuits is, like I said, you always have a way to check your work. So how am I going to check my work? Well, what I can do is, in series, the voltages add up. So the voltage of the battery is equal to V1 plus V2 plus V3. So what I'm going to do is I'm going to check my work because I'm going to find the voltage drop across each resistor, and if they add up to the battery, I know everything I did is 100% correct. Okay? Now we're going to have to use this method when we get to complex circuits. So how do I do that? Well, I'm going to apply Ohm's law. I know V is equal to IR. So V1 is I1 times R1. So it's 0.275 amps times R1, which is 6.75 ohms, and that comes out to be 1.86 volts. V2 is equal to I2 times R2, which is 0.275 amps times 15.3 ohms, which comes out to be 4.2 volts. V3 is equal to 0.275 amps times 21.6 ohms, which comes out to be 5.94 volts. Now, here's the great thing about circuits. Remember, the total is going to be this plus this plus this. So now when I add these up, it should come out to be 12 volts. Now, because you're, significant figures and stuff like that, maybe it might come out to be like, and how you're rounding on your calculator, it might come out to be like 11.98 or 12 point, you know what I'm saying? But these should add up to the source. And when they do, I know I didn't make a mistake. And this is the method that we're going to use. So in this particular problem, they didn't ask me to do that, but I went ahead and did that anyway. Now, I don't remember if I put the table in the back of your notes. I did, but we're just going to do it. For tonight's homework, we're doing series. So we're going to end up with current. Actually, usually I start with resistance, current, and voltage. So if you have a table like this, today we're going to do the series part, and this is what you have to memorize. So we know that in series, the resistances add up. So RT, this is the equivalent resistance, is equal to R1 plus R2 plus R3. And do you see where I'm calling it T for total because it makes it easier in saying like equivalent or effective? The current is the same. So IT is equal to I1 is equal to I2 is equal to I3. And then the voltages add up. So VT is equal to V1 plus V2 plus V3. So this is what we need to know for series. And then next class we're going to do parallel. And that's it.